Alright, my dear children, now we do a topic related to simple harmonic motion, that is called force law or simple harmonic motion. And with this force law, even we measure the time period, okay, of simple harmonic motion. Now, as you know, when simple harmonic motion when particle execute simple harmonic motion, okay, the direction of force and the acceleration is always towards the mean position or in a direction opposite to the displacement. And the force and the acceleration is always directly proportional to the displacement of the particle. Okay, so when a particle executes simple harmonic motion, every particle has a what? Mass. So I don't let m be the what? Mass of the particle. Let m be the mass of a particle executing what motion? Particle executing what motion? Simple harmonic motion. Now, the force exerted on the particle, okay, the force exerted on the particle can be measured when you know the acceleration of the particle. And we have done already, children, the acceleration of the particle is measured by this relation. The acceleration of a what? Particle at any instant of time. At any what? Instant of time is given by alpha, and this alpha equals to minus omega square y. And you know this omega means angular velocity, angular frequency. This is also called angular frequency, also called angular velocity also. And this y is called the displacement. This y is the what? Displacement. And this relation, which measures the acceleration, also say that the acceleration is directly proportional to displacement, and the direction acceleration is opposite to the what? Displacement. So this is the acceleration. But with this acceleration, we measure the force. But in order to measure the force, we follow Newton's second law of motion. Now I write down now from which law? From Newton's second law of motion. Now from Newton's second law of motion. Second law of motion. So if you go through Newton's second law of motion, Newton's second law of motion measures the force, and force is measured by mass into acceleration, and we use the acceleration by symbol alpha. So why I am using alpha? Because A is the symbol we have already used as amplitude. So that's why I am writing acceleration by the symbol alpha. So this is force. Now let me substitute the value. F equals to m into alpha means what? Minus omega square what? Y. Which means F equals to minus m omega square what? Y. M omega square what? Y. Now in this relation, if you see, m and omega square is basically constant. This is basically constant because the mass of the particle remains constant, the angular velocity also remains constant, which means F equals to minus, okay, let me write k as a constant into y. Okay, and this constant k, which is m omega square, is also called as force constant. This is also called force, or also we use the what? Spring constant. Spring constant also we use. Okay. Therefore, this force, as we have written just as F equals to minus ky. Okay. But look at this relation. Even this relation says that F is proportional to minus y. See, force is directly proportional to minus y because k is constant, which means the force is directly proportional to displacement in simple harmonic motion, and the direction of force is opposite to the displacement because this negative sign indicates the direction of force is opposite to the displacement. Okay. Now with this value of k, F equals to minus ky, we can even measure the angular velocity or frequency of the particle in terms of the constant called force constant. Okay. Now in order to write that, you just follow the relation. Okay. And the relation is what? Since F equals to minus ky, okay, F equals to what? Minus ky. Okay. Now instead of force, I write F equals to minus m omega square y, because we have already done from Newton's second law of motion. F equals to minus m omega square y equals to what? Minus ky. So this y and y cancel out, minus and minus and cancel out, which means omega square equals to k a by m, because this m I'll take in the denominator, making omega square as the subject. Now to calculate omega, that is angular frequency, it will be square root of k by m. So look at this relation, children. So in case of simple harmonic motion, the frequency of this angular frequency of simple harmonic motion, omega is equals to square root of k by m, where k is a spring of force constant. And this angular frequency, children, we measure as by the unit, and you know what the unit is? Radian per second. Yes, we have learned in a chapter called uniform circular motion. Uniform circular what? Motion. And this force which exert on the particle whose direction is towards opposite or displacement particle, and force direct from the displacement particle is also called as what force? Restoring force. Yes, you have learned already. What force? Restoring force. Okay. So once this is the angular frequency of the particle, then we can also write from this relation the time period of the particle. But in order to write the time period, we write this frequency in terms of the frequency of the particle, the frequency of the oscillation of the particle. Now the relation is, since you know omega equals to 2 pi mu. See, omega angular frequency equals to 2 pi, and this nu is called the frequency of oscillation. The frequency of oscillation of particle. Oscillation of particle. And you know nu frequency equals to 1 by t. Frequency and time period are reciprocal to each other. Yes, we have done it this way. That's why omega equals to 2 pi by t. See, if I replace this nu by 1 by t, so omega is always 2 pi by t. That's why, children, you know the relation between omega and t is given by this. Angular frequency is always equal to 2 pi by t. Now, let me calculate the time period from this relation. Omega how much? Square root of k by m equals to 2 pi by what? T. Now, let me make t as the subject. So, just cross multiply. Okay, let me cross multiply, or let me just do reciprocal. So, if I take reciprocal both sides, I write on square root of k by m as square root of m by k. Now, if I reciprocal right hand side 2 pi by t, I write on t by 2 pi. Okay, now I'll make t as a subject. If I make t as a subject, then this 2 pi will go in the numerator. 2 pi square root of m by k. So, look at the relation, children, that measure the time period of the particle. Time period in simple harmonic motion. So, the time period in simple harmonic motion is given by t equals to 2 pi square root of m by k, where m is the mass of the particle, k is the force or spring constant. So, this relation measures the time period in what? Simple harmonic motion. Now, in the next YouTube video, we will be learning the total energy of the particle in simple harmonic motion.